So here's a quick explanation as to why this thing has a problem with the drainage. Basically, if we come up here above the level, a little bit above the grade, you can see that this building with the corrugated iron roof, which is ancient, is up against this bank. Can't see the slope of it very well, possibly. But this thing gets waterlogged right around here, and this drain pipe is not in its normal position during the rainy season. This is just for summer. And the water infiltrates underneath the concrete block wall that you see here on the right, particularly at the seam here where apparently it wasn't sealed properly and the drainage was not created proper for it. So this room fills up with water, which is at the same level as the house slab, and the water gets into the house and voila, you get flooding. Okay, so here's the setup I came up with the help of my wizard friend. He gave me this nice 12-volt battery, you see on the right, where I rigged up with a couple of cheap clamps and a cut up household extension cord, polarized extension cord, and there is our 12-volt supply for when the power goes off. Normally, if it's raining and there's power, I'll have a 12-volt AC to DC converter there with the same kind of end. And then the infamous $11 pumps from West Marine, where I again connected their wires to a standard polarized thing. Do not plug this into 120 volts. That will destroy these things instantly. So probably. Anyway, and then one with a longer cord built the same way. They can both plug into here, and since it's polarized, everything is hunky-dory. Okay, apparently what this is, a piece of cast iron, you can see, that the original owner had sunk into the concrete there. Apparently what he did is he poured it full of concrete here and drilled a hole in there, and I guess this was intended to be some kind of a drain or something, but it doesn't work very well. It fills up, and that little tiny hole just lets the whole thing fill up and flood the room. So this thing had to go. If anybody wants that, there it is. So here's the first sump. It just got cut today by the concrete cutter guy with the bilge pump, and there's the wire which goes down here. It's not going to be this messy and ugly when it's raining. Connected to these AC things that I adapted to go up to the battery. And so the other pump is in this sump. And you can see the green hose is the outlet from the first sump, and the gray hose is going to be the outlet from the second sump, which will go all the way down here through the subway, as you can see along the side of the house there, and then into this existing drain that was built with a house. It drains all the way down to the street, way down this way, as you can see in this long view. That's about 40 feet to the edge of the property. And this drain never fills up, and it's good. So now we're going to use a hose and run water into the first sump at a pretty high rate, a lot higher than normally these things fill up during the winter. And the advantage of the battery is if the power goes out, then hopefully the thing will keep pumping and draining, and this room will not flood and therefore flood the house. So the first pump appears to be keeping up with the hose. I've got it turned on fairly strongly, but the sump is not filling up, but it's also not draining, so it's still running. Go back over to number 2 here. This should come on pretty soon. It's filling up here. I've tested the little pumps with their little rotating float switch. So this one should come up, and here it comes on. For some reason they have different sounds. I don't know why, but Hopefully I've got them polarity wired right and it's going to work. Now this one's got a long run, but not very high rise. It's only got to pump up a couple feet. So let's go over here and see if any water comes out the outlet here. Sure enough, here it is. And it's coming out at a pretty good rate and draining down into this thing. So proof of concept.